Weird. Weird.
In this lesson, we're going to talk about virtual memory. Virtual memory, also known as cooling features like the fans used in active cooling and other things like that. Next, we'll be conducting a demonstration so you can learn how to configure the various settings within the BIOS on a 32-bit system. And then, we'll move into a demonstration of the configuration settings within a Uefi-based 64-bit system so you can see the differences that occur when you're configuring a BIOS-based system and a Uefi-based system. Finally, we'll take a short checkpoint quiz to check your knowledge and then review the results to know why the right answers were right and the wrong answers were wrong. So, if you're ready, let's get started with our coverage of the BIOS and Uefi in this section of the course. We're going to talk about boot options that are set inside of your BIOS or UEFI. Now, the BIOS, or Basic Input Output System, is the program that a personal computer's microprocessor is going to use to get that computer system started and booted up after you turn it on. This BIOS is also going to manage the data flow between the computer's operating system and the attached devices, such as the storage devices like a hard disk drive or solid-state drive, a video adapter, the keyboard, and the printer. This is the most common example of firmware or software. This BIOS is also going to manage the data flow between the computer's operating system and the attached devices, such as the storage devices like a hard disk drive or solid-state drive, a video adapter, the keyboard, and the printer. This is the most common example of firmware or software on a chip, and it is the first software that's run by the computer whenever you power on the machine. Now, the BIOS has several roles, including performing the power on self-test, which is going to test and initialize the processor, video card, disk drives, and adapters, as well as configuring the hardware of your system and setting up the proper boot order to execute when that system is first powered on. The BIOS is stored in ROM, and ROM is read-only memory. This is a type of chip that is actually embedded into your motherboard, but it can be upgraded through a process known as flashing. The BIOS is also a program inside of this chip, and that program allows the user to make changes to the settings, and those settings are going to be saved in something known as the CMOS. The CMOS
What is that? What does that mean when he says it manages data flow between OS and devices for the
He's
ROM
referring to
chip?
the role of a device driver or controller. It acts as a
He's talking about the BIOS or Uefi. He manages data flow between OS and devices. I don't understand.
That phrase refers to the BIOS or UEFI firmware. It's the low-level software on your motherboard that initializes hardware and acts as a bridge between your operating system and the devices in your computer, ensuring they can communicate and work together properly.
Is that another term for hardware configuration, saying that it manages data flow between OS and devices? Like, does it just create the connection, or is it itself the bridge?
The BIOS or UEFI acts as the bridge itself. It initializes hardware and provides routines that let the operating system communicate with devices. Once the OS...
But it creates the bridge, or it itself is the bridge?
The BIOS or UEFI itself is the bridge. It sets up the hardware and provides the interface so your operating system can communicate with devices.
So is it like you go the CPU or the OS? Where is the OS stored in this storage?
The operating system is stored on your computer's main storage drive, like an SSD or HDD. The BIOS or UEFI helps the system find and load that operating system when you power on.
But is the operating system, in order for it to, the operating system is just a chunk of code, right?
Yes, the
operating system is just a chunk of code. Then what like, I don't understand. In order for the operating system to actually be doing stuff, doesn't it have to exist within the CPU cache?
Exactly. At startup, the BIOS or UEFI loads the OS from storage into main memory, RAM. Then the CPU pulls instructions from RAM using its cache for quick access.
Okay, so it just pulls the OS to RAM.
Right. The firmware pulls the OS files from storage into RAM, and then the CPU executes them from there so the system can run.
So, but when he says, okay, so he gave me like 4 separate features that the BIOS or Uefi. Is there a term to describe that? Is it just a firmware ROM chip, or how do I is there a better?
You can call it firmware stored on a ROM chip. BIOS or UEFI is the firmware that initializes hardware and helps the OS start up.
Okay. So I'll just call it like a firmware ROM chip?
Yes.
Okay, so for the firmware ROM chip, is that... I think the BIOS or Uefi is better, actually. Okay, so the firmware, or the BIOS Uefi, it does... so far, I've been told that it does 4 things. Those 4 things include managing data flow between the OS and devices, number 2, post, number 3, hardware configuration, and number 4, boot order. So when you said it puts the OS in RAM, is that just talking about the boot order, or is it talking about managing data flow between OS and devices? Or is that not really listed within the 4?
Loading the OS into RAM is part of the boot process, which is tied to the boot order. Managing data flow between the OS and devices is an ongoing role after the system boots.
Okay, so basically, maybe we could go through the steps. So doesn't the first thing that the ROM chip does is post?
Exactly. When you power on, the firmware runs the power on self-test.
Okay, that's the very first thing that the BIOS or Uefi does.
Yes, the first.
Okay.
After post, it applies your hardware settings.
Okay, so post. And what is post?
Post stands for power on self-test.
What does it do?
Post runs quick tests on your... It verifies that components like memory, processors, and storage devices are working correctly before handing control over to the operator.
Verifies that hardware devices work, basically.
Exactly. Post checks that hardware devices like RAM, CPU, and storage work properly before the operating system starts.
Okay, so that's first. That's first. And then next, the next thing is, after it does that, Then it does what?
After the post, the firmware follows the boot order to find a device with a valid.
So it does, before it does hardware configuration, it does boot order?
Yes. After post, it checks the boot order to find the device to load the OS. Hardware configuration can be adjusted through firmware settings, but it's separate from those initial steps.
But does hardware configuration happen after boot order?
Hardware configuration is usually set up before boot, but you can change those settings anytime in the BIOS or
So hardware configuration is just, it happens before post
No, hardware configuration typically happens after post.
and before boot order.
Hardware configuration is something you adjust in the firmware settings before boot, but the firmware applies those settings during post and uses them when deciding the boot order. In short, you configure hardware settings.
So during post, it verifies that the hard devices work, and then it also configures those hardware devices, or?
Post mainly tests and verifies devices. Actual configuration is done through the firmware settings menus, either before or after. Once set, post uses those settings to verify everything is working.
Okay, I don't understand. Does the hardware configuration happen like every single time the computer is turned on, or it only happens once?
The hardware settings you choose in the firmware stay saved. Each time you power on, post uses those saved settings to check hardware. So configuration happens once, and the system uses it every boot.
But does it have to configure them, or like I know you can have configuration settings, but does it have to apply those configuration settings every time, or no?
It applies the saved settings automatically each time you boot. So you
And that happen. It applies those settings during post, before post, when?
The firmware settings you've saved are applied automatically every boot. Post happens right after power on, using those settings to check hardware.
So it happens before or after post?
It happens before post. When you power on, the firmware reads the saved settings, then post uses them to test the hardware.
Okay, so it applies those hardware settings, and it configures the hardware?
Yes, it applies the stored hardware settings automatically at each boot.
Okay, so it configures hardware, and then it does post.
The firmware reads your saved hardware settings first, then runs post using those settings to verify everything works. Let me know if you need clarification on any of those steps or how they work together.
Is there a word for hardware configuration?
It's often called BIOS settings or firmware configuration. Basically, the settings menu where you adjust hardware options like boot order.
Hardware. Can I just call it HC for hardware configuration?
You could say HC informally, but in most discussions, people just say hardware configuration or BIOS settings to avoid confusion.
And that happened. BIOS. Say it again.
The BIOS or UEFI applies your stored hardware configuration settings each time you boot.
Okay, but it applies this before post.
Yes, the firmware applies the saved hardware settings first, and then runs post using those settings.
Okay, and then it runs the boot order.
Exactly. After post, it follows the boot order to load the operating system.
Okay,
I'm here if you have any more questions or need.
self-test. Okay, so
Let me know.
Hold on.
Whenever you're ready, just let me know what you'd like to explore further.
Okay, so the boot order is going to, what is there a specific order after the BIOS occurs?
Yes, after the BIOS or UEFI runs post and applies your configuration, it follows the boot order, checking devices in the sequence you've set, like SSD, USB, then network, to find and load the operating system. Then, once it finds a bootable device, it loads the OS from there into Right.
It looks for devices to run.
Could you tell me what you want to ask? I'm here to help. I'm happy to clarify anything. Just let me know the specific question you're thinking of.
My Wave XLR keeps automatically lowering the sound, and I don't know why.
Auto leveling or noise suppression settings could be causing that.
Why?
It could be due to Windows or Mac input settings, a software auto gain feature.
What should I look up to change that?
Search for Stop Windows 10 Automatic Volume Adjustments or Disable Communications Auto Ducking in Windows.
But what should I search for on my computer settings? Like, you could just tell me how to do it. I don't need to find a video that tells me how to do it. You just tell me how to do it, so tell me how to do it.
To stop a Wave XLR from lowering your volume automatically, check the Windows sound settings. Go to Control.
Setting. Sound mixer options, manage output sound devices, change system sounds, manage input sound devices.
Head to Manage Input Sound Devices and select your Wave XLR. There you can adjust levels and disable any automatic settings. If you don't see those options, open the Wave XLR software directly and look for any automatic gain or leveling controls to turn off.
Okay.
If you need more precise steps, let me know what operating system you're on, and I can guide you further.
I don't see anything about automatically changing volume.
In Windows, check under the Sound settings, specifically the Communications tab, and set Do Nothing, so the system doesn't adjust the volume. Also look in the Wave XLR software for any auto gain or compressor settings. If you're on Mac or another OS, let me
I'm
know.
on Windows.
On Windows, open the Sound Control panel, go to the Recording tab.
Where's Sound Control Panel? Is that not in my normal settings? I have to look that up somewhere else.
It's separate from the normal Windows settings. Press the Windows key, type Control Panel, open it, then go to Hardware and Sound and select Sound. From there, you can find the Sound Control Panel options.
I don't understand this. It says Windows can automatically adjust the volume of different sounds when you're using your PC to place or retrieve telephone calls. Is this the thing that's lowering my volume, you think?
Yes, that's likely the cause. Set that option to Do Nothing under the Communications tab, and it should stop automatic volume changes. Select your Wave XLR. There,
Change that.
I'm here to help. That.
Why?
It could be due to Windows or Mac input settings, a software auto gain feature.
What should I look up to change that?
Search for Stop Windows 10 Automatic Volume Adjustments or Disable Communications Auto Ducking in Windows.
But what should I search for on my computer settings? Like, you could just tell me how to do it. I don't need to find a video that tells me how to do it. You just tell me how to do it. So tell me how to do it.
To stop a Wave XLR from lowering your volume automatically, check the Windows sound settings. Go to Control.
Sound mixer options, manage output sound devices, change system sounds, manage input sound devices.
Once you set it to do nothing, your Wave.
So when we talk about boot order, we're just saying that it's going through the order, looking for devices to run the operating system. There's an order that it goes through to run the operating system.
Exactly.
But all it's doing is just trying to run the operating system.
Yes, the firmware's job is to find a device with a valid operating system and hand off control to it. If you want to adjust that order,
so it's really just three things. It configures hardware, it goes through post to test the hardware, and then it tries to run the operating system.
Right.
When it says manages data flow between OS and devices, does that fit into any of the three that we just talked about, or?
Managing data flow between the OS and devices is part of the ongoing role of the firmware after boot. Once the OS is loaded, drivers in the OS handle most of the data flow. The 3 steps we discussed are more about getting the system ready to hand off control to the OS.
So the BIOS or Uefi isn't just used for at the beginning until the OS. It's used even after the OS is running.
The BIOS or UEFI sets up hardware and passes control to the OS. After that, the OS and drivers handle data flow. The firmware stays in the background for tasks like power management or firmware updates, but it's the OS doing most of the work when the system is running.
So is the OS the thing that manages data flow, or it says that the BIOS Uefi is the thing that manages data flow between OS and devices? I don't really understand that.
The firmware sets up basic communication so the OS can talk to the hardware, but once the OS loads, it takes over managing data flow. Think of BIOS UEFI as the initial setup, and
so is that what it talks about when it's saying configures hardware?
Yes, in the context of BIOS or UEFI, configures hardware refers to setting up the essential hardware parameters so the OS can communicate with devices properly.
Gotcha.
Is the
All right, so then next we have changes in settings goes to CMOS. CMOS could be this. Is the CMOS battery like the same size as the ROM chip, or? No, the firmware. The not RAM, but the BIOS Uefi chips. What's the size difference? Is it like half the size, a quarter the size? It's roughly about half the size. Okay. And the CMOS battery, one thing that it does, at least in relation to the BIOS or Uefi, is it's going to maintain BIOS. Can I just call it B/U settings? BIOS Uefi settings. The BIOS is used with 32-bit processors, and the Uefi is used with 64-bit processors, or BIOS is a 32-bit chip. But he said something about BIOS being 32-bit and Uefi being 64, but I don't really understand that. Okay, so you're just saying that he's wrong.
In this section of the course, we're going to be covering the BIOS and Uefi. 64-bit processors too. This newer version, known as UEFI operating systems, CPU is going to use.
It says that the BIOS supports 32-bit processors, and then the Uefi supports 64-bit processors. I don't really get it. So BIOS was like more made for 32-bit processors, and Uefi was made for 64-bit processors, but that doesn't mean that they can only be used for those types of processors. Okay. And the CMOS maintains the BIOS Uefi settings, right?
To start, CMOS is the complementary metal oxide semiconductor, and it's a battery-powered memory chip. This is a non-volatile type of memory that stores the BIOS settings, and it's built into the motherboard. As long as the battery power remains, the DC current is going to be provided to the CMOS, and this allows the settings to be retained by that motherboard and by that BIOS. If the computer is constantly losing its settings or forgetting the date and time, this is usually an indication that that battery needs to be replaced. This battery normally lasts about 3 years, but on newer...
So the BIOS Uefi also keeps the date and time, which is going to be, is that the network time protocol? Like it uses the network time protocol, or how does it work? Okay, so it keeps basically what it does is the time comes from the CMOS battery, but that CMOS's time can change. The OS can change that time, ensuring that it lines up with the NTP.
For CMOSs, these can actually use an internal lithium-ion battery that can last up to 10 years. The most typical external battery that's going to be used with these CMOSs is known as the CR2032, and this looks like a watch battery. Now remember, if the battery begins to fail, The first thing the user is going to notice is that system clock is going to forget the date and time frequently. So if you find yourself changing your date and time a lot, this indicates that your battery is most likely dying. Now, when you press the power button on your computer, the first thing that happens when power is applied is we begin the boot process. And the first step is the power on self-test, which is known as the post. The power on self-test is a diagnostic testing sequence that a computer's basic input-output system, or the starting program, is going to run to determine if the computer's keyboard, RAM, disk drives, storage devices, and other hardware are all working properly. If the necessary hardware is detected and it's found to be operating properly, the computer can then begin to boot up. If the hardware is not detected or it's found to not be operating properly, the BIOS will issue an error message, which could be a text message on your screen, or if your screen is having a problem, it could be a series of coded beeps depending on the nature of your specific problem. Since the post runs before the computer's video card is activated, it may not be possible to display everything to your screen, and therefore we're going to use these variable beeps as a way to tell you what's wrong with the system. These beeps can be short and long, or a mixture of detected, or it's found to not be operating properly, the BIOS will issue an error message, which could be a text message on your screen, or if your screen is having a problem, it could be a series of coded beeps depending on the nature of your specific problem. Since the post runs before the computer's video card is activated, it may not be possible to display everything to your screen, and therefore we're going to use these variable beeps as a way to tell you what's wrong with the system. These beeps can be short and long, or a mixture of short and long beeps, depending on what type of BIOS is installed by your motherboard. The exact pattern of beeps is going to contain messages about the nature of the problem that it found. For example, if the keyboard is not detected, a particular pattern of beeps might inform you of that by sending 2 short and 1 long beep, something like beep beep boop. Now, the post can also have errors that are fatal, and if this is the case, it'll cause the current program to stop running and it will halt the boot process. This is important to understand because the hardware that's being checked by this post test is all the essential hardware, things like it'll cause the current program to stop running and it will halt the boot process. This is important to understand. A particular pattern of beeps might inform you of that by sending 2 short and 1 long beep, something like beep beep boop. Now, the post can also have errors that are fatal, and if this is the case, it'll cause the current program to stop running and it will halt the boot process. This is important to understand because the hardware that's being checked by this post test is all the essential hardware, things like your memory, your keyboard, your input-output devices, and your processor. So if there's any error in any of these things, it will stop the boot process because it can't go and load a full operating system with faulty hardware. Now, once your post does successfully happen, this will then allow the BIOS to read the settings from the CMOS, and the BIOS will then look for an operating system from your configured boot devices. The BIOS also has its own low-level operating system of sorts for that computer, which allows it to take input and give output to the most basic components, including your keyboard, your disk drives, and the video display. Using its low-level ability to read from the storage device, the BIOS will then try to find your installed operating system, something like Windows or Linux or Mac OS, and then the operating system's bootloader is going to begin the operating system boot up process. The BIOS also has its own low-level operating system of sorts for that computer, which allows it to take input and give output to the most basic components, including your keyboard, your disk drives, and the video hardware. Now, once your post does successfully happen, this will then allow the BIOS to read the settings from the CMOS, and the BIOS will then look for an operating system from your configured boot devices. The BIOS also has its own low-level operating system of sorts for that computer, which allows it to take input and give output to the most basic components, including your keyboard, your disk drives, and the video display. Using its low-level ability to read from the storage device, the BIOS will then try to find your installed operating system, something like Windows or Linux or Mac OS, and then the operating system's bootloader is going to begin the operating system boot up process and turns over control of the computer over to that operating system. Now, the BIOS also stores its settings and configurations in the CMOS, like I said before, but you're probably wondering, how do you change those settings? Well, to configure those settings inside of the CMOS, you need to enter the BIOS configuration environment. To do this, you're going to be pressing a valid key or combination of keys during the boot up process, and this is going to be set up by your manufacturer of your BIOS. The most commonly used keys for this is F2 or delete, but this does vary depending on the BIOS and the motherboard that you're using, and I've seen other keys like the escape key, F1, F10, and F12 being used. Usually, when you first turn on the system, there'll be a message on your screen that will tell you which keystroke is required in order to change its configuration settings. If you don't see that displayed, you can simply do a quick search online at the manufacturer's website, and this will tell you which keystroke is being used by your particular system. Now, traditionally, there was only a single type of BIOS, which relied fully on a text-based menu system and the keyboard as its system of input. This traditional BIOS provided the user with the ability to view information on memory, CPU, manufacturer's website, and this will tell you which keystroke is being used by your particular system. Now, traditionally, there was only a single type of BIOS and F12 being used. Usually, when you first turn on the system, there will be a message on your screen that will tell you which keystroke is required in order to change its configuration settings. If you don't see that displayed, you can simply do a quick search online at the there will be a message on your screen that will tell you which keystroke is required in order to change its configuration settings. If you don't see that displayed, you can simply do a quick search online at the manufacturer's website, and this will tell you which keystroke is being used by your particular system. Now, traditionally, there was only a single type of BIOS, which relied fully on a text-based menu system and the keyboard as its system of input. This traditional BIOS provided the user with the ability to view information on memory, CPU, optical drives, and storage devices. While these weren't very graphically appealing, these text-based systems did provide all the necessary functionality in order to configure your device, your boot order, your clock speeds, the date, the time, whether or not you're going to enable virtualization support, security features, and lots of other things like that. Now, modern systems, though, have started switching over from this traditional BIOS and instead are using something known as the UEFI. The UEFI, or
Yeah, I did that weird.
Uefi, as we like to call it, is the Unified Extensible Firmware Interface, and it's basically an updated form of BIOS that allows both the keyboard and mouse as input, as well as providing a graphical user interface instead of that standard text-based menu. These systems tend to be more intuitive for you to use because they have that graphical user interface instead of a text-based menu system, and they still provide all the necessary functionality to configure your devices, your boot order, your clock speeds, your date and time, the virtualization support options, security features, and lots of other things, including rates. Now, some of these Uefi-based systems also include software in them that will allow you to go online, play some basic games, and even use backup programs without ever having to enter into a normal operating system like Windows, Linux, or Mac OS, and this makes them very powerful. Now, Uefi has several advantages over the traditional BIOS. First, the traditional BIOS only operates as a 32-bit system, whereas Uefi can support 64-bit systems. Second, Uefi can support larger hard disk drives and solid-state devices. The traditional BIOS can only support storage devices up to 2.2 terabytes in size, but the Uefi can support drives up to 9.4 zettabytes in size.
What does that mean when he says the Uefi can support larger hard disk drives and solid-state drives? What does it mean to support them?
It means UEFI can handle drives larger than 2 terabytes and use modern partition schemes like GPT, so the system can boot from and fully access bigger and newer storage devices.
Okay, so it's just how much of the storage drive they can access?
Right. Older BIOS
That
systems
is
had
9.4
limits on
times 10 to the 21st bytes. That would be an extremely large drive, and right now, none of those actually exist. But for this reason, Uefi gives us lots of capability well into the future. The third thing we have is that the traditional BIOS only supports using a master boot record, which is known as an MBR, and this is your storage device partition table that tells you how the things are stored on your given hard drive or solid-state device. But Uefi can actually support the newer GUID or GUID partition table format, which is known as the GPT. Now, this new format of GPT supports larger hard disks and storage devices, and it's required for any device that is going to be larger than 2.2 terabytes in size. Fourth, the Uefi tends to be faster than a traditional BIOS in terms of booting up a system, so this is another increased benefit for us. And fifth, the Uefi usually uses a larger size ROM than a traditional BIOS, and so it can actually support more complicated programs, including that GUI-based configuration tool that we talked about earlier that's included with most Uefi-based
When he says it uses a larger ROM, is he meaning the actual chip is larger, or the chip can just hold more memory itself?
systems, and this gives you better diagnostic tools and commands that you can use during your troubleshooting. Now, regardless of whether you're going to use a traditional BIOS or a newer Uefi-based system, you're going to be using this configuration tool to set up the boot order and the parameters for your system. This will allow you to determine which devices are going to be read from when you're trying to find the operating system, such as Windows, Linux, or Mac OS, for the system to be able to load. This could be your fixed storage device, something like a hard disk drive or a solid-state device, but you could also store it on an optical drive, like a CD, DVD, or Blu-ray. Will allow you to determine which devices are going to be read from when you're trying to find the operating system, such as Windows, Linux, or Mac OS, for the system to be able to load. This could be your fixed storage device, something like a hard disk drive or a solid-state device, but you could also store it on an optical drive, like a CD, DVD, or Blu-ray, or a USB drive, like a thumb drive or flash drive, or you might even use a network adapter to reach out to a server using the pre-execution environment known as PXE as your desired boot option. All of these are valid choices, and it does depend on your use case, so it's an important thing for you to configure inside your BIOS or Uefi as you pick out the prioritized list or boot order that you want to use. For example, let's say you have yours set up to be the optical drive first, then the hard disk, then the USB, and then finally the network. This means when you turn on your computer, the system is first going to look to your optical drive to see if it can find a bootable operating system there. If it does, it's going to load it up, but if it doesn't, it's going to move on to your second priority, which we listed as the hard disk drive. Now, when it looks at your hard drive, it might find that Windows is installed. So it's going to then load up Windows and turn over control of the system to the Windows operating system, and it won't go any further down its boot list. But this particular order can actually be dangerous for you because there's a lot of operating systems out there that can be run from an optical drive or a USB thumb drive, such as certain versions of Linux. So, as an attacker, if I can insert my Kali Linux DVD into your optical drive and power on your computer, I can now use your hardware and be able to bypass all of your passwords because I'm now loading up Kali Linux instead of Windows, and so I don't need to hack into your Windows account to use your system anymore. At this point, from inside Kali Linux, I can mount your hard drive to read your files and things like that. But again, I would have to have physical access to your system to put that DVD into your drive. So, for this reason, in most corporate environments, we like to use a best practice of disabling booting from an optical drive or USB drive to prevent attackers from taking over your systems in this way. Instead, you should configure your system to boot from your installed hard drive using the operating system you installed, or if you're using a thin client, you may choose to boot the operating system over the network using PXE as your primary option, and then not selecting optical drives or USB drives at all inside your priority list. Now, the final thing we need to discuss with the BIOS and UEFI is how to update it. And then your installed hard drive using the operating system you installed, or if you're using a thin client, you may choose to boot the operating system over the network using PXE.
Is thin client a VDI?
A thin client is a lightweight computer that relies on a server to run applications, while VDI, virtual desktop infrastructure, is the technology that provides those virtual desktops on a server. They
So
work together.
VDI is the technology that provides thin clients?
Thin clients are simple computers that rely on a server for most processing. VDI, virtual desktop.
So thin clients use VDI.
Exactly.
exe as your primary option, and then not selecting optical drives or USB drives at all inside your priority list. Now, the final thing we need to discuss with the BIOS and UEFI is how to update it, because this is software after all, even if it is software on a chip or firmware. Now, to update the BIOS or UEFI, you need to use a process known as flashing. Flashing is performed whenever there are upgrades, security fixes, or feature improvements that need to be made to the BIOS or UEFI codebase. Always check the manufacturer's website for the latest firmware version and their specific process for flashing your BIOS or UEFI. In the old days, our systems actually didn't have the ability to flash the BIOS, and instead we had to actually replace the entire BIOS chip on the motherboard. But thankfully, all modern motherboards now support flashing, so we can simply overwrite the BIOS or UEFI using this specialized procedure. Now, before flashing the BIOS or the UEFI, you should always back up your configuration and information first, just in case something does go wrong. In most systems, you're going to need a USB flash drive to flash your firmware. You'll then load a file into the root of that USB flash drive, connect the flash drive to a specified USB port on your motherboard, and then reboot your configuration and information first. Just in case something does or the UEFI, you should always back up your configuration and information first, just in case something does go wrong. In most systems, you're going to need a USB flash drive to flash your firmware. You'll then load a file into the root of that USB flash drive, connect the flash drive to a specified USB.
Okay, you're just talking the process of flashing, so back up. Okay, so this is just like the stuff you kind of want to do. So you want to back up.
Go wrong. In most systems, you're going to need a USB flash drive to flash your firmware. You'll then load a file into the root of that USB flash drive.
Load a file into the root of the USB drive. No idea what the fuck that means. Load a file to the root of the USB flash drive.
Directly onto the USB without putting it inside any folders. Just plug in the drive, open it in your file explorer, and drop the file right at the top level so it's not inside any subfolders.
The root of the USB drive means the USB drive can have multiple root folders, and it's just saying for it to be its own root folder and not to be inside of any other folder.
Not quite. Each USB drive has just one root, the top level. When you open the drive and see no folders, that's the root. You're simply placing the file there without nesting it inside any folder.
So there can only be one non-nested. Everything else is nested.
Exactly. The root is that single top level. Everything else on the USB is
But can you have multiple things within the root?
Yes, you can have multiple files and folders in the root of the USB drive. The root just means the top level directory. Each file or folder
Load a file, the root. Okay, so I'll just say root file, backup, root file. I'll say file to root.
Connect the flash drive to a specified USB port on your motherboard, and then reboot.
Connect to USB port. But I'm on the motherboard, then reboot the system. But I don't understand. So you can do that on your own computer. So I can connect the USB drive. I can get the settings. Like, where do I get these settings from? A file? I just download the file online or something? Okay, so I just download the file, put that file into my root, and then, so first I back up my settings. And what do I back up my settings? How do I do that? What does that mean? Okay, so you can just save your you can just save your configuration settings into the flash drive as well. Okay, so you back up if possible, and then is that what he's talking about when he says back up? Is to export the configuration to USB or to manually do it? Okay, yeah. So backup settings, then you file, and you can do that in a USB drive. Maybe you're manually writing them down. Then you put the file into the. You go to the website and get the file and put it into the root of the USB drive. Okay, and then after that, then you have the file into the USB drive. So now you're going to like what disconnect that USB drive and then turn off your computer and then plug it back in and then boot up your computer and it should automatically go to that or something like that. Okay, so do you have to not plug it back? Can you just leave it plugged in, or you have to unplug it? Okay, sure. So you just leave it plugged in, you turn it off, then you turn it back on, and then. But he says 3, connect the flash drive to the USB port on the motherboard, then reboot the system. But it should, in order to load the file into the root, then you already need to have it, the drive plugged into the motherboard. No. Say that again. So why is he saying connect the flash drive to the USB port on the motherboard if it's already done, if it should already be like that? Okay, but in order to load the file into the root, it doesn't need to be connected to the motherboard?
The system.
Okay, gotcha. Okay, gotcha.
While pressing a series of specified keys or pushing a specific button on the back of your motherboard. Then, the BIOS or Uefi will take over, copy the firmware to the system, and overwrite its old code with that newly updated firmware code.
Okay, I don't know if I need to know all that, but yeah. Flashing just refers to essentially using a USB drive with the new settings and loading up your computer with those new BIOS settings on the USB drive. Okay. Updates. Is that how you update any firmware? But that's how you would have to update your BIOS or Uefi.
In this lesson, we're going to explore some of the security features inside of the BIOS and the Uefi. In addition to providing protections on our network and in our operating system environment, we also need to consider the security of our pre-operating system environment. This is the area of the computer that can be attacked during the boot up phase, and therefore, the bootloader protections must be considered. including the BIOS and Uefi passwords, the secure boot process, and the setting of permissions on your motherboard's USB ports. Remember, the BIOS and Uefi are two different types of firmware that's used in our computers to assist us during the loading and booting up of our operating system. Each computer can have either the BIOS or the Uefi in our operating system environment. We also need to consider the security of our pre-operating system environment. This is the area of the computer that can be attacked during the boot up phase, and therefore, the bootloader protections must be considered, including the BIOS and Uefi passwords, the secure boot process, and the setting of permissions on your motherboard's USB ports. Remember, the BIOS and Uefi system environment, we also need to consider the security of our pre-operating system environment. This is the area of the computer that can be attacked during the boot up phase, and therefore, the bootloader protections.
Pre-operating system environment. That is just once, like it's essentially before you. Oh, it's before the operating system. Okay, so okay.
Must be considered, including the BIOS and Uefi passwords, the secure boot process, and the setting of permissions on your motherboard's USB ports. Remember, the BIOS and Uefi are two different types of firmware that's used in our computers to assist us during the loading and booting up of our operating system. Each computer can have either the BIOS or the Uefi in it, but not both. The BIOS is the basic input-output system, and it's a firmware interface that initializes hardware for an operating system in order for it to boot up. The computers that rely on BIOS are going to use a master boot record, or MBR, to hold their boot information and identify the partitions of a given hard drive that contain the operating system to load.
So the MBR is where it holds its boot order. But I don't understand. The BIOS or Uefi settings are stored in CMOS. Isn't the MBR considered a setting, or? So where does the MBR exist within the? Where does the MBR exist? Okay. And the storage drive is typically going to be way bigger.
BIOS is the older, more legacy type of firmware. Uefi, or the Unified Extensible Firmware Interface, on the other hand, is a newer type of firmware. The Uefi is a type of system firmware that provides support for 64-bit CPU operations at boot time, a full graphical user interface and mouse operations at boot, and better boot security. Computers that rely on Uefi are going to use a GUID partition table, known as GPT, to hold their boot information. Uefi provides the ability to access and boot from disks over 2 terabytes in size, and provides CPU-independent architecture and drivers, as well as a pre-OS environment. This, on the other hand, is a newer type of firmware. The Uefi is a type of system firmware that provides support for 64-bit CPU operations at boot time, a full graphical user interface and mouse operations at boot, and better boot security. Computers that rely on Uefi are going to use a GUID partition table, known as GPT, to hold their boot information. Uefi provides the ability to access and boot from disks over 2 terabytes in size and provides CPU-independent architecture and drivers, as well as a pre-OS environment that can...
I don't understand if the NVR exists at the very beginning of a hard drive and the BIOS or Uefi, the BIOS is limited in terms of the hard drive that it can access. It's talking about the aspects of the hard drive that it can access, right? Like, why can both of them... A hard drive at the very beginning of a hard drive is going to look the same if it exists at the very beginning. Do you get what I'm saying? Yeah, so the BIOS might not be able to see the entire storage device, but if it's larger than 2 terabytes, but it can still get to the NVR at the beginning. But why does it need to? No, why does it need to see the rest of the drive? Why doesn't it only need the NVR? Why does it need to read the entire disk? But what data would it need to access from the storage drive other than the NVR? But all of that exists in the NVR, right? Oh, okay. So the NVR just contains the order, and then once you get the order, then the actual operating system could live beyond that 2 terabytes, and that's why the BIOS wouldn't work. But theoretically, if you had a storage drive that was larger than 2 terabytes, the BIOS might not be able to access the whole thing, but let's say that you weren't using anything past the 2 terabytes, then the BIOS should be able to access it, right?
Include network capability and web browsing access. Overall, Uefi is newer and more advanced than BIOS and provides additional security and integrity checks during the boot process, including secure boot. Now, the BIOS and Uefi can be protected using a few different types of passwords too. This includes the supervisor, administrator, or setup password, the user or system password, and the storage or hard drive password. The supervisor, administrator, or setup password is the first type of password that you're going to find when you're using the BIOS or Uefi. This password is used to protect the access to the BIOS or Uefi's configuration program and prevents unauthorized users from accessing this sensitive configuration tool. If you set this password up, anytime somebody tries to enter the BIOS or Uefi, it's going to require them to enter the password prior to granting access, but it won't prevent somebody from powering on the computer and booting up into the normal operating system environment. This password is almost always going to be set up on computers in a corporate or enterprise network so that your end users can't access the BIOS.
So the supervisor or administrator password is just about getting into the actual BIOS or Uefi?
Administrators and technicians can if they have the right password. The user or system password is the second type of password that can be configured in the BIOS or Uefi. This password is used to lock access to the entire computer. Whenever the computer is powered on, it's going to stop and ask for a password. If the end user enters the correct password, the computer is going to continue to load the operating system and boot up. While this is the computer is powered on, it's going to stop and ask for a password. If the end user enters the correct password, the computer is going to continue to load the operating system and boot up. While this is a very secure method of protecting a computer, it's almost never used in corporate or enterprise networks because this password would have to be shared with all of the users. password. If the end user enters the correct password, the computer is going to continue to load the operating system and boot up. While this is a very secure method of protecting a computer, it's almost never used in corporate or enterprise networks because this password would have to be shared with all of the users who access that computer, and this shared password then negates some of that security that we're trying to gain. Instead, you're usually going to see a user or system password used only on somebody's computer when they're the only user on it. This is a separate and different password than the user password that's going to be used to access Windows, Linux, or the Mac OS system, and instead grants the user access to the system in that pre-operating system environment. The third type of password is known as a storage or hard drive password. This type of password used to be very popular prior to the inclusion of the Trusted Platform Module or Hardware Security Module in modern computers. This password would lock access to a hard drive that's connected to a system and would require the end user to enter the password in order for that hard disk to be read from and the operating system loaded. Unlike that user or system password that locks the user out of the entire system and would require the end user to enter the password in order for that hard disk to be read from and the operating system loaded. Unlike that user or system password that locks the user out of the entire system until the proper password is entered, the storage or hard drive password will only lock them out of the hard drive.
Hard drive refers when he talks about the storage or hard drive password. When he says that, he's talking about either HDDs or SSDs, right?
And the ability to boot that operating system from it. The next security feature we need to cover is known as Secure Boot. Secure Boot can be enabled in the Uefi interface and settings and is not supported by BIOS. If enabled, it's going to perform 3 different verifications during the boot up process for Windows or other operating systems.
Oh, really?
Systems that support this capability boot that operating system from it. The next security feature we need to cover is known as Secure Boot. Secure Boot can be enabled in the Uefi interface and settings and is not supported by BIOS. If enabled, it's going to perform 3 different verifications during the boot up process for Windows or other operating systems that support this capability in order to ensure the computer has not been hijacked by some kind of malicious code injected into the operating during the boot up process for Windows or operating system from it. The next security feature we need to cover is known as Secure Boot. Secure Boot can be enabled in the Uefi interface and settings and is not supported by BIOS. If enabled, it's going to perform 3 different verifications during the boot up process for Windows or other operating systems that support this capability in order to ensure the computer has not been hijacked by some kind of malicious code injected into the operating system. Let's take a look at the full boot up process on a normal Windows system. The
Okay, so he talks about the BCH, which is going to be the BIOS/UEFI password, the computer password, and then the hardware password. Those passwords are not saved within the firmware ROM trip of the BIOS or UEFI, is it?
Yes, BIOS or UEFI firmware is stored in a ROM or flash chip on the motherboard. Flashing updates that firmware. If you have more questions about
Yeah, my question is, does the BIOS password, the BIOS/UEFI password, and the computer system password and the hard drive password, do those all exist within the BIOS or UEFI chip, or are those settings stored somewhere else?
the BIOS or UEFI and hard drive passwords are stored in firmware on the motherboard or on the drive itself, not on the operating system. This ensures they remain secure even if the OS is compromised. If you need more detail,
Where are they stored?
they're stored in non-volatile memory on the motherboard, specifically the system's firmware like the BIOS UEFI chip.
So they're stored within the BIOS chip, the passwords.
Yes, those passwords are typically stored in non-volatile memory on the motherboard, often within or alongside.
First step in the process occurs when a Windows computer is starting up, the firmware boot components are loaded, and the boot manager is started. Next, the Windows loader is going to begin, the Windows kernel is going to be started, and the boot critical driver installations are going to occur. Now, any additional operating system initializations are going to happen, and finally, the user is presented with the Windows login screen. When the firmware boot components are loaded during a secure boot, the firmware is first going to verify that all the Uefi executable files and the OS loader itself have their integrity intact and they haven't been compromised by any kind of malware. This means they're going to be safe to load up. Next, the Windows boot components are going to verify the digital signature of each component prior to loading them. If any component fails this signature check, it's not going to load and it's going to trigger an alert to the end user. Finally, the boot critical drivers are going to be checked against their known good hashes, and if they pass this check, they're going to be loaded up as the final part of the secure boot process. Now, when it comes to secure boot, I want you to remember that this is a procedure that's going to be used to ensure that our operating system itself can be trusted and it's not fallen victim to a special type of malware known as a rootkit. For secure boot to work, it has to be enabled inside of your Uefi system, and your operating system also has to support it. The final security feature we need to cover within the BIOS or Uefi is setting up permissions for your USB ports on your motherboard. Most modern systems can be configured to enable or disable the USB ports on your motherboard, and some will even allow you to restrict the USB ports so that they're not going to support certain has to support it. The final security feature we need to cover within the BIOS or Uefi is setting up permissions for your USB ports on your motherboard. Most modern systems can be configured to enable or disable the USB ports on your motherboard, and some will even allow you to restrict the USB ports so that they're not going to support certain types of USB devices while still allowing others to be used. Now, the big concern here is normally going to be with malware and data loss. In terms of malware, USB ports can provide a great avenue of attack for somebody who's trying to break into your system. For example, if I load up a USB thumb drive with some malware, I can drop it in a parking lot outside of an office building. And if somebody's curious and picks it up and plugs it into their machine, that can then install malware onto your systems. So we want to prevent this by disabling the ability of USB to read and write from mass storage devices. You can do this by either blocking USB altogether, then you wouldn't be able to use things like headphones and webcams, mice and keyboards and things like that. So instead, we might want to just restrict the ability to use them as mass storage devices, and this would prevent anything like USB thumb drives or flash drives or external hard drives from being connected to the system. This can help us to prevent malware from being introduced into our system, but in addition to that, it also can help us prevent data from getting out of our system. For example, let's say you work for a top secret organization within the government. You wouldn't want somebody to be able to walk in with a small USB thumb drive, plug it into the computer, and download all of your information and then walk out the front door with it. So to prevent this, you can actually configure your Uefi to block those USB ports or to prevent them from being used for mass storage devices, and again, blocking the ability to use thumb drives and external hard drives, which will make it so people can't walk out the front door with your critical information. So remember, when it comes to security, there's three main things that your BIOS or Uefi can provide you with. The first is the ability to set passwords to control different access to different parts of your system. The second is the ability to enable secure boot to ensure your operating system has not been compromised prior to loading it. And third is the ability to restrict or disable USB ports on your motherboard to prevent malware from being introduced into the system or data from being exfiltrated from your system. In this lesson, we're going to talk about the Trusted Platform Module, or TPM, and the Hardware Security Module, or HSM, that exists as part of your Uefi. But first, I want to introduce you to the hardware root of trust, known as the ROT. Now, a hardware root of trust is the foundation on which all secure operations of a computing system depend. It contains the keys used for cryptographic functions and enables a secure boot process. This is inherently trusted, and therefore it must be secure by design. Now, a hardware root of trust is a cryptographic module embedded within a computer system that can endorse trusted execution and attest to the boot settings and metrics. This may sound like a complicated concept, but you use a root of trust all the time. In fact, the TPM module inside your computer's Uefi is a hardware root of trust. Essentially, a root of trust is going to be used to scan the boot metrics to the system and the operating system files.
I don't understand what that means. He says a root of trust is used to scan the boot metrics in the OS files.